Let's begin with a drum set. Listen for an explosive live sound. The snare should be crisp and the cymbals should ring. If they become harsh or flat, the speaker's high frequency response is peaky or distorted. The snare should be crisp and the cymbals should ring. Snare should be crisp, cymbals should ring. Let's begin.
Speakers. Most of us use them every day, but how does it work? A speaker is basically a small air pump. When something vibrates, it moves the air particles around it. Those air particles in turn move the air particles around them, carrying the pulse of the vibration through the air as sound. First, sound travels as electrical current from amplifier to the speaker's crossover, which typically separates a frequency's range into three separate parts: high frequencies, mid-range frequencies, and low frequencies. Each driver produces sound waves by rapidly vibrating a flexible cone or diaphragm. The cone, usually made of paper, plastic, or metal, is attached on the wide end to the suspension. The suspension is a rim of flexible material that allows the cone to move and is attached to the driver's metal frame, called the basket. The narrow end of the cone is connected to the voice coil. This mechanism is attached to the basket by another ring of flexible material called the spider, which allows it to move freely back and forth. This motion is generated by an electromagnet. An electromagnet is a coil of wire usually wrapped around a piece of magnetic metal, such as iron. Running electrical current through the wire creates a magnetic field around the coil, magnetizing the metal it wraps around. This field acts just like the magnetic field around a permanent magnet. It has a positive end and a negative end. But unlike a permanent magnet, an electromagnet, you can alter the orientation of the poles. If you reverse the flow of the current, the positive and negative ends of the electromagnet switch. The electromagnet is positioned inside a constant magnetic field created by a permanent magnet. These two magnets, the electromagnet and the permanent magnet, interact with each other as any other two magnets do. The positive end of the electromagnet is attracted to the negative pole of the permanent magnetic field. The negative pole of the electromagnet is repelled by the permanent magnet's negative pole. When the electromagnet's polar orientation switches, so does the direction of repulsion and attraction. In this way, the alternating current constantly reverses the magnetic forces between the voice coil and the permanent magnet. This pushes the coil back and forth rapidly, like a piston. When the coil moves, it pushes and pulls on the speaker cone. This vibrates the air in front of the speaker, creating sound waves. This electrical audio signal can also be interpreted as a wave. The frequency and amplitude of this wave, which represents the original sound wave, dictates the rate and distance that the voice coil moves. This in turn determines the frequency and amplitude of the sound waves produced by the diaphragm. Your ear then interprets a fluctuation in air pressure as sound.